So, what is version control? Well, let's imagine for a moment that you are an artist who has been dropping some dope rhymes for Rizzle.
Know what I'm saying?
But after you've written this amazing masterpiece, your editor, who's trying to appeal to a wider audience, has a bunch of suggestions or edits that he'd like you to make. So you incorporate these. And after you incorporate these, he comes back with more. Once again, you reluctantly agree, but deep down you know that you have a shell of what you used to have, of your creative vision, and you would like to get that original version back. Now, if as you've been making these changes, you've been overwriting your old versions, unfortunately, you can't get it back. And that's where version control systems come to save the day. In fact, you've probably interacted with a version control system in the past, the classic system, where, as you make changes, you store them as separate copies. And then you have version 3, and then version 3 done, and bada bing, bada boom, every time you make a change, you store a separate copy. This is a version control system. It controls multiple versions, and if you ever need to get an old version back, you can. And if this is all you need, awesome. You don't have to watch the rest of the video. Congrats. But in reality, when it comes to lots and lots of revisions, this can be a little bit cumbersome. So the simplest form of a version control system is a linear system. These systems simply store copies as time goes on. In fact, if you've worked with Google Docs, you are familiar with this as well. Google Docs has linear version control built right in. You can always just scroll back time and see what things looked like before. Now, this is also great, but doesn't cover quite everything. Specifically, what happens if you're working with a friend on this project? Now, you've made a version 3A, and they've made a version 3B, and you need to incorporate changes from both your version and their version. How can you do this? Well, that's where non-linear version control systems come into play. This has the property that every version can have multiple versions that come after it, and supports merging these versions back into a single one in the future. And usually they have a number of strategies of doing so. And now we come to the crux of the video, Git. The actual version control system that pretty much everyone uses nowadays, particularly if you're working with software development. Now, there are a few other ones, and if you are using one of the other types of version control, I'm so sorry. I'm so sorry. My heart goes out to you. So, how does Git actually work in practice? Well, the first concept you have to understand is the idea of a commit. A commit is Git's term for a snapshot of the repository. It's a complete copy. So here we have a single file, and we're going to call that our initial commit. Now, we can make changes to that file and make subsequent commits. And anytime we need to, we can jump back to an older version and see what things looked like then. And importantly, when we're at that older version, we can also make new versions from there, and we can go down a different path and make different changes. And we can jump back and forth as needed wherever we need to in this version tree. And finally, Git also supports merging, taking changes from two separate branches and merging them into one commit. So, that's great, but how do you actually use it? Well, first things first, you've got to create a Git repository. How do you create that first Git repository? Step 1, install Git. Hopefully you can figure that one out by yourself. Google's a really great resource, but if not, I'll leave a link down in the description. After you've got Git installed though, you're going to need to run the command git init. This creates an empty repository so that you can start storing your snapshots or commits. So, how do you make a commit? Well, the first step is you need to make a change. So, in this situation, we have a file that has hello in it. Step 1 of making a commit is make your changes. I'm going to add that glorious world to round out the hello world. After you make that change, it's been updated on the file system in your computer, or what I'll call the working directory. Now, before you can commit it, you need to add it to the staging area. Now in Git, the staging area is a collection of changes since the last commit that are going to be in the next commit. So we can do this by doing git add and then the name of the file, and then those changes are put into the staging area. Once you have all the changes you want to commit in your staging area, you can make the commit by simply typing git commit -m and then a message, just so that you remember the changes that you made here. Make sure to have a commit message that's useful. It's important. After you do that, bam! You've just created your first commit. Congratulations. But if you're ever confused, there's a command, git status, which will tell you which changes are going to be committed and are in the staging area, and which changes aren't in the staging area. It's a very helpful command whenever you're confused. Git status, it's like a good friend, You just, anytime, it's really helpful. Now, we've talked about making commits, and we can string together a few of them, but how do you go back and check out that older version? I mean, that's the whole point of version control, right? Being able to look at the older versions? Well, we're gonna get to that in a second, but before we do, I wanna talk about head. What is your head in Git? Well, your head is the most recent commit and a direction for where your next commit is going to go. Now, in this case, we're on the main branch, and you can think of a branch as an invisible line. Our most recent commit is this initial commit here, and our head is pointing towards that main branch. So, as we add commits, they're gonna be added to that branch, and our head is gonna be updated to be the most recent commit. Awesome. So, how do we check out that older version of commit? Say I wanna see what things were like back at this commit X here. The first thing I need to do is run git log. Now, git log is going to print out a unique identifier for every single commit. Once I have the identifier for the commit I want to check out, all I do is take that identifier and run git checkout that identifier. And then bada bing, bada boom, we get to go back in time and see what things looked like after that commit. But the keen-eyed among you may notice that there's no arrow pointing anywhere anymore. And that's a great observation. Good job. Now, what would happen if we made a commit right now? If we made a change and then added and committed it, where would it go? The answer is, that's undefined. We're in what's called detached head state. And has a hot tip. If you're ever trying to do research about how detached head state works in Git, be very certain that you specify that you're talking about Git and not the head attached to shoulders. Also, do you enjoy that dog in the background? Bruh. Alrighty, so we're on this older commit, and we do want to make a change from here. Well, the next concept we need to worry about is branching. Now, to create a new branch, all we need to do is type git branch and then the name of the new branch. And this is going to create another one of these invisible lines. Look at that, there's a new branch here. Awesome, but we're still not pointing to it. To point our head to this new branch, we need to run git switch and then the name of the branch. And this is going to point us to that new branch. Now, the next commit that we make is going to go on the branch add z. Fantastic. Also, that git switch command is super helpful. You can jump back to the main branch, see what things look like here. Or you can jump back to the add z branch, see what things look like there. The power is limitless. And if you're ever lost, here's a great command to help you figure out where you are. Git log, and then some extra fun things here that make it print out real prettily. And this is going to give you something like this. And just to show you how to read this, it's saying our head is pointing to main and that we're on this commit, remove X. And also that there is another branch, add Z, over here with the commit add Z. Whenever you're confused about what branch you're on or what commits are leading up to that branch, this is a great command to help you figure it out. Okay, now don't panic, but here comes the scary part. What happens when we have two commits on separate branches and we want to incorporate both of those changes into a single commit? Now, let's imagine that we're on the main branch and there's that other branch named add Z that has different changes to what we have. The way that we incorporate both of these changes into a single commit would be using the command git merge and then the name of the branch you'd like to merge in. What this does is it takes the changes from both branches and puts them together into your working directory. And it's going to put it in this sort of format where it can say the things that came from the branch are below all the equal signs, and the things that came from my head, or the branch I'm currently on, is above the equal sign. And it's going to actually put that into your files. All you need to do to deal with this merge conflict is delete those and put things together however it makes sense to put them together. Unfortunately, Git isn't magic and can't do this for you, but some good deductive reasoning usually helps here. Once you've made these changes in the working directory, all you need to do is add those changes and then commit them, almost like you treat every other commit. And bada bing, bada boom, look at that. We've merged these two branches together. That wasn't too hard now, was it? Now, let's dive in and see what this looks like in action. So, here I have a completely empty directory. The first step is to initialize it so that we can start tracking versions using Git. To do this, we need to run git init. Wonderful. Now we've got an empty repository. Fantastic. But now we need something to keep versions of. So I'm going to create a new file. I'm going to call it hello.txt. And here we're going to put hello. Wonderful. So let's create our first commit. Real quick, let's run git status. And here we can see we have an untracked file, hello.txt. So it's not going to be added to the next commit. First, we got to add it to the staging area, git add hello.txt, and then let's run git status again. And now we can see that those changes are ready to be committed. And we can commit them with git commit -m and then initial commit. Fantastic. We've just created our first commit. Okay, let's make another one. So I'm going to come up here and I'm going to add a change. I'm going to say thing X. Fantastic. And then I'm going to do git add dot to add those changes, and then git commit -m add X. Fantastic. Now, if I want to make another change, I totally can. Just got to come edit the file, thing Y. And here's a hot tip. You can do the adding and the committing in one command. And that command is git commit -am and then add Y. And the A here tells Git to automatically add all of the changes that I've made. Wonderful. And just like we've added things, we can also remove things. So if I wanted to delete that, I could delete it and then run git status real quick, just so we can see. Look at that. There is a change, not staged for commit. Let's commit it using that special new command, git commit -am, and then remove X. Wonderful. And if we want to see those commits, we can by running git log. And this is going to show us those unique commit IDs as well as a list of all of the commits. So let's say we wanted to check out this one, that add X. We can just copy that commit ID and then run git checkout and that commit ID. Bam! Look at that. You can see it's jumped back to how things were right after that commit. We went back in time. And you'll also notice it gives us this big nasty message about detached head state. But you're an old pro, you know what that means. It means we can't make commits here. But what we can do is commit something to a new branch. To do that, first things first, git branch add Z. This is going to create a new branch. We're still not pointing to it. We're still in detached head state until we run git switch add Z. Look at that. Now we're pointing to the add Z branch. Alrighty, so let's make a change. We're going to add thing Z and then git commit -am add Z. And it's on that separate branch. If we want to go see what things were like back on the main branch, that's not too hard. Git switch main, and we're back on the main branch. Fantastic. And you can see right here that it actually updates the files whenever we switch back and forth. So if I do git switch back to add Z, we can see we have the Z and the X. And if we switch back to main, we can see we just have the Y. Alrighty, if I want to take those changes from that other branch and merge it into this main branch, I can do that with git merge and the name of that other branch. And look at this. It takes the changes from both of these and it puts them right into the same file. Now my IDE shows it a little special like this, but all it is some text showing these. And so what I want to do is come in and manually merge these. And remember, we wanted thing X deleted, so we're going to delete that. And here we go. We have done the merge. And to actually take that merge and commit it, just like every other commit, we can do git commit -am and then merge add Z. And look at that. We've merged it. Now, if we want to see all of those commits that we've made, we can run that special git log --all --graph command and take a quick look. So we can see right here, we're on the merge add Z. This is where our head is pointing to main. And we can see that we had a remove X and an add Y on the main branch, and that we had a add Z on this add Z branch. Fantastic. That wasn't so hard now, was it? Now, that was a great demo that showed you how to interact with Git, but we're missing one very important part, and that is that Git is better with friends, baby. So how do you work with other people on a Git repository? Great question. The first thing that you need to do is put Git, instead of just locally on your machine, have a repository on a remote server so that anyone can access it, or whoever you need to access it can access it. There are a number of managed Git servers out there. I'm talking your GitHub, your Bitbucket, your GitLab. There are lots of options out there. Whichever one you use doesn't really matter. You're gonna go and you're gonna create a repository in one of these services, and then come back to your local machine and point it to that server. The way that you point it to the remote server is by running git remote add origin and then the path to the repository on that server. Once you've pointed your local repository to that server, pushing your changes up so that other people can see it is as simple as git push origin, which is the name of that remote, and then main, the branch that you want to push to. And this is going to create a copy of your local repository up on the remote repository so that everyone can view it. Fantastic. Now, if you're someone else who wants to view one of these repositories that exists on one of those services, all you need to do is run git clone, provide that path to the repository, and that's going to take what's up there in the repository and pull it down onto your local machine. Now, whether you cloned the repository or you started with a repository locally and then pushed it up, you're going to be in this situation where you have a local repository and a repository on that remote server. From here, you can commit your changes locally and then run git push and then the remote origin and the branch main, and that's going to take your changes and push them up to the remote server. On the flip side, if someone else pushes their changes up to the server, you can pull them down to your local repository doing git pull origin main to specify where you're pulling from. That ain't so hard, is it? Well, you're probably thinking of the situation where someone else makes a change to the remote repository and you make a change to the local repository. And now, what happens when you try to push your changes? Well, I'll tell you. It gives you a scary message that says that your push failed. But don't panic, it's gonna be fine. We've actually seen this before when we had two separate branches that were different. Now, when you run git pull, it actually merges the remote repository into your local repository. So if these changes don't align, what it's going to do is take those changes from remote and the changes from local and put them into your working directory with that special bit that tells you where the changes came from. All you got to do, fix those merge conflicts and then add them and commit them, and bada bing, bada boom, look at that. We've dealt with that merge. And now when we run git push origin main, it's going to be smart enough to know that this commit comes after that commit and incorporates its changes so we can make that push. Fantastic. Now, hopefully that wasn't too scary, but just to show you that that's not actually that scary, let's have a demo that explicitly creates that issue where remote and local don't line up. Alrighty, so I want to take this repository and allow my friends to edit it. The first step to doing this is I'm going to jump over to GitHub, and I'm going to initialize the repository in GitHub so that I can then push my code up to there. To do this, we're going to go up into this plus in the top right, and then create a new repository. And I'm going to call it Hello Git. Fantastic. I'm going to create that repository. Now, if we jump back over here, we can point our local repository to that remote repository by doing git remote add origin, and then that repository, github.com, Aaron N. Brock /hello git. Now our repository is pointing there. And finally, to push our local repository to that remote repository, we have to do git push and then origin main. And bada bing, bada boom, if we jump over to GitHub and refresh the page, look at that. We see the repository. And this repository can be edited by my friends.
Hi, I'm Drew, definitely not Aaron, and I can clone repos too. So let's have a look at that. I'm going to start by cloning the repository from Aaron. So I've got my git clone command, and I've got Aaron's repo, the URL right there. So let's give that a go. So that's cloned the repository for me. The next thing to do is to go into that folder that was just cloned. So cloned and downloaded hello-git folder, and I can cd into that directory. In my VS Code editor, I'm going to open that folder just to make it nice and easy to see what's in there. Great, and I can see here that we've got one file here, hello.txt. So Aaron's already added a few things, but let's add some things of our own. So I'm going to make a change. I'm going to put in here, let's see, let's put thing Drew. I think that'll be all right. So I'm going to save that file. That's just a normal operation of editing that file by adding a new line. And so now what's really interesting is that we're already starting to see some changes in the VS Code editor, but let's stick with the terminal and have a look at what we need to do next. So I've made the change and I want to have a look at the state of things. So I want to do a git status to see what's happened. Now this is a common error that you might get if you do what I've just done and haven't changed into the directory correctly. So I'm just going to jump into our hello git directory, give it another go. That's a little bit better. I can see that I'm on the main branch. I can also see that I have some changes here. That change that I just made was picked up by Git. It is not in the staging area yet. So I've got to do something very special with Git to tell it that I want to add it to that staging area so I can proceed to the next steps. So I'm going to use the command git add, and I'm going to reference the file that I want to add with the changes in there. So git add hello.txt. So nice and simple. I do want to make sure that that command did exactly what I wanted it to do and that we're ready to go. So I'm going to run git status again. I'm going to check the state of things. And now we can see it's actually in green that the changes are ready to be committed, that we've modified hello.txt. This is great. This is exactly where we want to be right now. And so to make the changes, I actually have to make a commit. So I'm going to run git commit. I'm going to use -m with quotes for my message, and my message is going to be Drew's changes. This way Aaron knows through my commit message that I have made some changes, and he can see the changes that I did make once that gets sent over to him. So git commit -m. Git's told me that one file was changed with one line inserted or one insertion there. So that's really good. We're almost ready to go. I want to do a git status once again to show you what's happening under the hood there, or at least what's happening when we run each command. So I'm now one commit ahead. My branch is ahead of the remote branch that Aaron has access to. So this is really cool. We're a little bit ahead of him. He won't see this until I'm ready to push it. So I've got my commit lined up. I've got my commit happening, and locally I can see that there. The next step is to do a git push, and this is going to push to the remote. Now that that's happened, we can see we've communicated to the remote, we've pushed it. If I do a git status just one more time, we should see we are up to date. We're not ahead, we're not behind, everything's in sync. Over to you, Aaron.
Thanks for making those changes, Drew. Now, I could pull Drew's changes by running git pull origin main, since he pushed them up to the repository. But instead of doing that, let's make our own changes and see what happens when we try to push them. I'm going to come and edit this file, just like we've done before, and add thing Aaron. And now I'm going to commit those changes. I'm going to do git commit -am and then add Aaron. Fantastic. Now if I run git status, we're going to see something special, which says that your branch and origin main have diverged. So what this is telling me is that there's a commit on the remote that I don't have locally, and there's a commit locally that I don't have on the remote. So what's going to happen when we run git push origin main? Place your bets. That's right. We're going to get a rejected push. This is because those changes don't align, and Git wants us to incorporate those changes before we push it to the repository. But never fear. We can pull those changes and deal with that merge conflict by running git pull origin main. And just like when we merged before, it puts both of them into the repository like so. All we have to do is deal with these changes. I'm going to have both thing Aaron and thing Drew, and look at that. Just like we dealt with the merge conflict before, after that, all we got to do is git commit -am merge Drew's changes. And there we go. We've dealt with the changes, and now when we do that git push origin main, it succeeds. And we can jump over to GitHub and take a look at the repository. Just by refreshing it, here we go. We can see that when I look at hello.txt, it has both of those changes. That wasn't too hard now, was it? Congratulations. Now you have a basic understanding of what Git is and how to use it. To do a quick recap, We started out by initializing a repository. Then we created multiple commits, taking snapshots of changes that we've made along the way. We used git checkout to look at an older version of the repository. Then, from that older version of the repository, we created a new branch and added changes to that new branch. Finally, we merged those branches together so that we could incorporate the changes from both of them. After that, we pushed our changes to a remote repository on GitHub, where both myself and my good friend Drew made changes, but at the same time, and we dealt with the problem that caused in that merge conflict. It wasn't really all that scary. Hopefully, you have a good enough understanding of Git to understand this XKCD comment. Yeah, it's a great comment. As always, I'll give you a second to observe. And that's all, folks. Hopefully you enjoyed this video. I sure enjoyed trying to make it. By the way, I didn't mention this, but I'm sitting outside. Hopefully the noise wasn't too bad. If it was, I'm so sorry. I don't know. I live in a van now. Like, this is my life. I don't have access to nice, happy indoor facilities. So, hopefully you found this useful, found this interesting, had a good time. I don't really know. If there are any topics you want to see me cover, please leave a comment down below. And maybe I'll get to them in like 6 months or something. I don't know. I'm pretty sporadic about this. So here's a call for action you don't get too often. Say you're tired of the dystopian LinkedIn feed that you have. You can add me on LinkedIn and I'll bring wonderful memes into it. Do you like cloud-related memes? Well, turns out I'm the #1 contributor for Google Cloud memes on the Google Cloud subreddit. Follow that subreddit for great memes like this one. Hopefully you found this useful. Remember to follow me on LinkedIn. Bye.